Today's presentation is Information Management Support Tools for Breeding. Many opportunities to support complex processes are afforded by the integration of plant breeding and information technology. For this reason, SIP developed an online global trial data management system with access to potato and sweet potato portals, where readers can find information about specific protocols, catalogs, and are able to use the breeding tools applications, where the key components are crossing management, botanical seed inventory system, pedigree book, and roots and tubers base, among others. Plant breeding is a process of developing improved varieties of plants with desirable traits from existing ones. The process of crossing two or more plants together to obtain offspring with new desirable characters as a result of genetic recombination is called hybridization, and is perhaps the most important moment in a breeding program. This is why the outline of today's presentation is about the SIP cross, which involves the crossing management, the botanical seed inventory system, the pedigree book, and a use case for potato. The generation and management of new cross progenies entail much handwork, including record keeping, which is time-consuming and highly subjected to human error. In an illustrative case study, seed potato breeders carried out 3 crossing plants per season, in which 950 crosses per plant were performed, and 5 labels were generated for each cross. At the time of crossing, there is development, there is harvest, seed cleaning, seed packaging, and seed storage. In the end, a total of 14,250 crosses labels were written by hand during 336 person hours. Reports were generated manually by technical staff and typed by the research staff to store the information on their personal computers, in which are isolated from each other and from the institutional database. In this link here, there's available e-learning material about this process. The solution for these disadvantages, typographical errors in labels, long man hours, and isolated and non-integrated data in a database were solved by the development of the SIP cross. This system is a botanical seed inventory tracking system for clonal crop breeding that enables tracking of breeding materials from crossing blocks and botanical seed inventories all the way through to seed distribution. SIPcross is open source software available online and comprises 2 main tools, the crossing management system and the botanical seed inventory system. The crossing management system uses the main development platforms Visual Basic 2008 for Windows Mobile OS and Microsoft SQL Server Compact 3.5 Windows Mobile software. This tool facilitates the barcode labeling of parents and crosses, storing the information in a database and generating automated reports. This equipment, the Pocket PC and portable printer, are water, heat, cold, and shock resistant and can last long hours without the need to charge them. This is very important for the greenhouse and field work. The reports save all raw data collected throughout the entire process. In this example, the attributes considered for the female and male parents were color of skin and shape of tuber. Now we'll see how the data is generated.
Good morning, everybody. I am Raul, and I'm going to show you a short demonstration of the SIP cross system. No, this is logout. This is the Global Trial Data Management System. This is an open web page where all the breeding tools applications are developed at SIP are stored, can be found, and specifically the tools that make up the SIP cross system, like the SIP cross application, the SIP inventory system, and the Pedigree book system.
Excuse me, Raul.
Sorry?
So we still see the slides. It is supposed to be.
You're okay. No, es que solo estás compartiendo el slide. Pero no.
Arriba el dispositivo verde.
Ya.
¿Cuál es Chrome? Primero, ajá. Eso creo que sección. Está bien.
Yeah. Okay. Now can you see
Yes.
the web page?
Yes.
Okay. Okay, so this is the Global Trial Data Management System. As I was saying, this is an open web page where all the breeding tools applications are can be found. All the tools developed here at SIP, and specifically these tools that make up the SIP cross system, such as the SIP cross application, the SIP inventory system, and the Pedigree book system. First, I'm going to talk a little about the SIP cross. We clicked on find out more, and here we have general information like it runs on Windows Mobile OS for Pocket PC, and some technical details like the current version, the file size, and we have the download button to download the file to be installed in the device. Some other software needed for the application to run correctly, like the database for the Pocket PC, the QR code reader, the setups for the printer. The SIP Cross uses a portable printer, and it communicates via Bluetooth. The SIP Cross also works with a template that the breeders must download and fill. So there are some general information, technical details. To download the template, we must select a crop and the genetic study. In this case, I'm going to select breeding selection, and we clicked on download. Se cerró de nuevo el mobile. ¿Dónde está poniendo la mesa? No, so all the information that the SIP Cross works with is going to be written down by the breeder on this template. Let me show you how the template, an empty template, looks like. No sé si lo ven. Can you see the Excel file?
Yes.
Okay, so this is how an empty template looks like. This is the minimal data. I'm going to explain you a little more with an example that has already data. And there are sheets for the crossing plans, 1 up to 10. Here I have one that is already filled with data, a real data. Let me show this one. Yes. Okay. Can you see the Excel file?
Yes.
Okay. So this is a template. In fact, this is a real case for a breeding campaign in June 2016. So all the templates has a unique ID, and all the crossing plans has also a unique ID, so it can be identified inside the application. The breeder must complete some location information like the country, admin, localities, and the locality itself. In this case, the experimental station of Santa Ana in Huancayo. The name of the people authorized to run this template in the application. They are usually technicians. Crossing locations like the greenhouses that where the crosses are going to be planted, and some optional data like the fruit size. And as I was saying, there are 1 up to 10 crossing plans or sheets for crossing plan. So the breeder must complete the plant name, the population, and a template method that is a crossing type. There are 2 options, A and B. I'm gonna explain you a little more after I explain these males, the parentals. So the breeder must paste a list of parentals that are going to be part of this campaign, like the accession number, there is the SIP number, the collection number, there is a name given by the breeder for this specific parental, and an attribute that is to show how the studies is going to be oriented. So we have an example of 2 plants here. So once the breeder has completed all the parentals, he selects the method. The method, there are 2, A and B. The method A is a random method where the technician is free to choose which female to which male he's going to cross. So this is mainly done for when a clone is tested for the first time. So to test how he or how the parentals can be combined. And the other is the method B, that is oriented, where these cells are used. So the breeder marks with an X which parentals are going to be crossed. So if the technician wants to cross, for example, in this case, 6 with female 6 with male 1, he won't be able. The application won't let him to do that. Only the crosses that were chosen by the breeder can be performed. This template is filled by the breeder and sent to the technicians in the experimental stations, and the technicians must load this into the Pocket PC to be read by the SIP Cross application. So let's go to the application itself. Okay. Let's see. Let's see the application. Yeah. Please give me a minute to set up the connection of the Pocket PC with the computer.
Okay.
Está conectada, sino que se movió la mesa. No se va a poder conectar, porque me voy a demorar unos minutos en arreglar esto.
Tranquilo, trata de conectarlo una vez más como era antes.
Esto modelo.
Volver a lanzar como tú hiciste.
Sí, a ver. Bien, antes se me conectó, pero no está moviendo la mesa. Ajá.
Okay, so I unmuted everyone. If you have questions, you can ask for the last 10 minutes presentations.
Yeah, hello?
No.
Yeah, while Roy is connecting the mobile device, anyone have questions and comments? So I have one question, if no one else have question. So when your method B orientations fixed based on the breeder's request, do you have a place to populate how many pollinations, the number of pollinations?
¿Cuántas cruces más o menos?
Uh,
How many crosses?
we usually perform by crossing walk. We can select example that all the parent that you want, like a female and male, and you can perform it all that you want to do. Example, in case of one for one plant breeding in potato, we usually have 1,000 crosses by one only for one plant. So we can have more in this because one plant you can have more of 1,000 crosses. This is it's clear? I don't know.
Right, for each cross, how many pollinations you may?
Well, for each cross, usually in the potato, we have the maximum number of flower we have is 12. So, but in average, for one process, we can pollination 8 flowers, but depends on the number of flowers we have in one inflorescence. But we can do the 12 is the maximum in case of potato by inflorescence.
Okay, yeah. So since Roy is connected, you can go ahead.
Yes.
Okay, so let's go ahead. Can you see the screen of the application?
Yeah.
Yes.
Sheet. Yeah, okay. So actually, or currently, there are 2 languages available, Spanish and English. I'm going to show you the English version. So the first step is to select the template file that just has been uploaded. This is the one I just showed you. Let's wait. Okay. Then we select the plan. And the user must select his name in the list of usernames, so all the information registered will be linked to this user. Sorry. Yeah, okay. So let's choose plan number 2. Wait. Yeah, plan number 1. There are some rules that must be yeah, not in the plan 2, not all the parentals have their attributes, so that's why the application says that it's not valid. This is a rule for the template. The users select the location, the green in this case greenhouse number 31, and we clicked on login. And the first screen one that we see is the parentals screen. No information is generated in this step. This is just for parental identification inside the greenhouses. We can select one or more parentals at a time, and we can choose the number of copies we want to print. This is mainly because a parental is not just planted once. It can be planted 2 or 3 or more times in the same greenhouses. So the technician usually print labels for the parentals, for the parents first, So they, once they have the pollen, they store it in a cold chamber, and then they plant the females about a month later. So the parentals, the donation must select the planting date. This is very important. And the parentals labels are like this one. I'm going to show you. Let me see. Oops. Are like this. There are the seed number, the collecting number, and the attributes, the planting date, the identification if it's a male or a female, and the number assigned by the breeder, the order number assigned in the template, and the barcode, the QR code that represents the seed number in this case. This is for the male, this is for the female example. So this is the labels that are printed by the application for the parental identification inside the greenhouses. And so the next step is the crossing step. Let me see. So here in the grids are listed all the parentals that were introduced or were written by the breeder in the template. These two boxes are for search. This can be, the seed number can be written manually, or it can be read using the QR code generated in the parentals labels. For this example, I want to choose female number 3 and male number 12. We select the cross, we check that the information is the correct one, and we must select the number of flowers. In average, in this campaign, we have 5 flowers per cross.
Mm-hmm.
In one inflorescence, 5 flowers. And
we can in one inflorescence we select because the technician counts the number of flower they need to pollinate in this moment. So the variation is the range is like to the 1 flower to 12 is the maximum number in the crop potatoes.
Okay, so the users also select the type of pollination. By default is selected the one that is in the template. We have crossing pollination, self-pollination, and bulk pollination. In this case, I'm gonna let it in the cross-pollination, the crossing date, and finally, once all is filled, the user clicks on print. So in this step, a label is printed and the information is stored. So this is the first step where information is generated. The label generated in this step is this one. They have the parentals, first the male, the female, and then the male, the order numbers, the number of flowers, and the crossing date. And in this step, a unique ID is generated and assigned to this cross that it will be used along all the SIP cross system. This is a unique ID. We have the plant name, the method, and a QR code that represents this ID that we call the inventory ID. We're going to see more about this in the next system, that is seed inventory, but just to mention this. Okay. The next step is the harvest step. Again, we have boxes for searching. And well, in a real case, the grid will be empty because the harvest is not made just right after the crossing. But after the user searches for a specific cross, this is how it looks. All the information we just generated, we select the cross. We enter the number of fruits. Again, on average, we have found that there are 5 fruits.
You pollinate 5 flowers, probably you find 5 berries or less than that.
So let's let's put 5 fruits, the harvest date, and again we click print, and a label is printed and the data is stored. Well, this cross is updated. If we see here, we have the number of flowers, and now we have the number of fruits and the harvest date. The label generated is like this. Is similar to the last one. We have the parental seed number, the number of flowers and the number of fruits, the crossing date and the harvest date. No, and the same information. This is keeping the inventory ID is the same. Okay, I put search. Okay. So the next step is the maceration. In this case, I'm going to, okay. For example, in this case, I have 2, and this is the one I am using for this example. It doesn't have maceration date yet. So I'm going to, in this, I select the cross, select the maceration date. I'm going to choose this date to see the difference. And we click on print. So again, a label is generated and the data is stored. In this case, we have that exact, just as we chose, the date of maceration is the 12th of April. And the label is this one. Again, the parental, the number of flowers, fruits, and the maceration date is added. And the last step is the seed count, where the technician writes the number of seeds generated for this cross. Again, we select the cross, we check this is actually the one we want to work with. We enter a number of seeds. Let's say 500. The seed count date, and again we click on print to save this information. And sorry, and if we go here, we have the seed total number is what we just introduced. So this is all the steps in the crossing process. And finally, we have a report generation. In this case, we just have 4 records because this is just an example, but in a real campaign, it can be more than 1,000 records. The technician can give the report a name. If no name is given, one by default will be given. And we generate this report. Let's see. We have some general information like where this is stored in the Pocket PC, the number of records, and the date it was generated. Let me show you how this one looks like. Let's go here. Let me see. This one. So this is how a report generated looks like. We have just 4 records. We have information taken from the template, the parentals. We have the crossing date. We have the user that performed the cross, the number of fruits, the fruits, again, the user that performed. That's why we required a user when to log in the application. And finally, the seed number, the seed count. And the only boxes that are empty are some boxes for the physical storage that will be written by the person in charge here in the seed quarters. So the users export this report and they send this to the headquarters for the breeders to complete this information. Here I have a real case or the real report for this template. Chiara, ¿dónde está? Let me- okay. So this is the real report for this template. As you can see, there are, we see, more than 1,000 crosses. This is the raw data. So when this report is sent here to the headquarters, a personnel is assigned this template, and it is cleaned and consolidated like this. It's a consolidated report that has 245 records.
Effective crosses.
Effective crosses. So these are the crosses that are going to be uploaded to the seed inventory system that I'm just going to show you. For example, in this case, they have assigned this, where this is. No, okay. Yeah. So once this template or this report is cleaned and consolidated, this is uploaded to the seed inventory system that is the next application I'm going to show you. So this is a general information. This is a web page for the seed inventory system. This is general information, some technical information, and let's go to the web page. Let's log in. This this web page is open, but all people with CGIAR accounts can log in just using the CGIAR account. So, but right now I am with an admin account. That's why I see all the options. But essentially, we users can see this screen, this table, where all the seeds of crosses, historical data is showed. For example, we have the parental information, the seed inventory generated in the seed cross. As I mentioned, it will identify this cross along all this seed cross system. We have the year of the cross and the physical location where it is stored here and the cold chambers in the seed headquarters. This is each breeder is assigned a shelf. The shelf is divided into lines. The lines are divided into boxes. And inside the boxes, there are some bags where the seeds are stored. And this is the total number of seeds that were generated in the campaign, and this is the stock. For example, in this case, already seeds has been already discounted. If we clicked in the seed inventory ID, we see the discounts, the dates of the discounts, and some additional information. Yeah, let me put this here. And also we can make discounts here. I'm not gonna make a discount right now, just to show you how it is done. So again, this is the historical discount information that the user can see. So the report is uploaded here by a person with the appropriate grants. Not all users can upload this information, just the people that the breeders assigned to be allowed to do this action. But CGIAR can log in and see this information. For example, in this case, for this, let's look for this specific information. We paste, we want to search by inventory ID, and in fact they are here. This corresponds to the Walter Amoros engineer, and this is just the information. Like, seed has been discounted. So why, or other way that the breeders uses this application is to choose which seeds they're going to assign seed families. Not all the seeds that are generated are going to be assigned seed number. So the breeder can use this platform to choose which seeds are going to be used, and
which crosses will be used in the,
which crosses will be used for the next step. So let me, okay, okay, oh, me salí del GTDMS. Yes. Yeah. So the next application is the Pedigree book system. As I told you, what I was saying, the breeder chooses which crosses are going to be used or assigned seed families. This is the web page of the Pedigree book system. This is general information, some templates for creation. So the people responsible to create must fill this template. Let's go to the application. Again, let's do this. Okay. Okay, so this is the Pedigree book system where all the crosses with seed families are stored. We have for potato and sweet potato, and let's see the families. This is all the families that are registered. We currently have 25,695 families, seed families for potato. And we have information of the breeding year, the seed family assigned to this cross, the information of the parentals. So all this information is directly linked with the seed inventory system. So all the databases are linked and synchronized. This is the SIP number that was assigned. It is made by the SIP, 3 letters SIP, the breeding type that can be number 3 for breeding and number 5 for pre-breeding. The year, let's find another year. Let's find, for example, in this case, we have SIP, this is breeding, for breeding, the year 2014, and the other 3 numbers are a sequence. We have, there are up to 999 families per year. We have, if we clicked on the SIP number, we can see the family tree for each cross. So this family tree is generated with a recursive algorithm and using the Pedigree database and also the seed inventory database. So, well, to create a new family, in this case, I have the grants for creating because I'm with an admin account. So once the breeder has chosen which crosses he's going to assign SIP numbers, for example, in this case, let's see, he wants this tree. It can be looked by inventory ID. All this information is gotten by or from the seed inventory database. He assigns some family codes, some remarks for this cross that will be converted to a family, some information about the breeder name, the population. As I was saying, there are 2 types, for the SIP number. Number 3 is for breeding, and number 5 is for pre-breeding. The breeding year, the breeding country, and the cycle. So I'm not going to create right now. This is just have to show you how a family is created. So this is the third and the last application that make up the SIP cross system. Right now, I'm going to pass to my colleague Chiara. She's going to continue with the presentation.
Hi, hello, my name is Chiara. I work at the breeding area. I'm going to explain all these steps my fellows share with you in a real example of breeding.
Hi, Chiara.
In this case,
yeah, you're showing two screens, unless that's what you tend to.
Okay. ¿Cómo? Solo una.
Compártele el screen.
Solo
O ayúdale a compartir el screen.
Okay.
Ask.
Now I'm showing.
No, lo has compartido.
Okay, it's one screen now.
One? Okay. I'm going to explain you this real example of a breeding case, potato breeding case. This is an accelerated multi-trait selection scheme for drought and heat tolerance, virus resistance, and early harvest in the population LTBR BHW. In this case, we have the first step is the crosses we performed in 2016. In Raul show you the seed cross, all the process. As you can see previously, we have like 1,000 crosses, but at the end we have only 245 records, and of those records, the breeder only select 111 families. They assign a SIP family number. I'm going to show you. I don't know if you can see in the 2017, the 111 families were selected, and for each family, we took 150 seeds each family. We planted in San Ramon, that is a place here in Peru that has a condition of heat, mainly, because this population we are going to select for drought and heat tolerance. And I'm going to show you. In 2018, this year, last year we harvested small tubers, and we send it to Lima, to the headquarters, so we can plant it in a greenhouse condition at first, and then we separate like a clean copy of these tubers, and another copy we send it to field, so we can do a phenotyping selection. Also, last year when we planted the families, we ran a molecular marker test. We took some leaf samples for each clone. I mean, it was 150 leaf samples for each family, and we send it to perform an analysis of molecular markers. In this case, for PBY, that is a virus that it's the main concern in SIP in this population, actually. And also we have some results of this test of the PBY, so we can add this information to the phenotypic information we are performing right now. I'll show you. Okay, so this is the greenhouse in San Ramon. We took some samples of these plants. Here is the preparation of the samples we sent to Interreg. It's a company that worked with us with these molecular markers, and they sent us then the information of these specific markers for PBY. We harvest all the tubers we planted, and then we plant these tubers in 2018 in summer here in Peru. I'll show you some photos. This is this year. Then we plant this GOBii to field under heat conditions, and also we are going to evaluate these clones for phenotypic characteristic like tuber appearance, tuber uniformity, stolons, and all this information, phenotypic information, we are going to cross with the information of the PBY molecular markers. I'm going to show you. Okay, so once we select we have a family material list. Here in SIP, we work with a tool that is called HideUp. I'm going to show you. This is HideUp. Okay. I can upload.
We still see the desktop.
Okay. Okay. Great. Now you see?
Yeah, HideUp, yeah.
Okay. This is a tool we use here in SIF to create field books. We have here material management. In this case, we have clone list and family list. In manage list, I already created this list because we are right now working. This is a real example. And I have here, okay, so I can make a clone list. Okay, so I'm choosing my list. These were the parentals we use in the seed cross. And we also have, okay, we also have the information of the family list. Here we can create a new field book, and I'm going to show you the real field book. Okay, this information is the information of the breeder he used to select the clones we are going to plant. Here are the physical information of the seed, where is storage, and the cold chamber, so we can select it. This is the family number that is assigned in the previous process. And we generate this, first the family list. We have all the families here with the pedigree, the female and the male accession numbers. And then from each family, we have 150 clones. So we generate a material list for each family.
Really?
I don't know if you can see. Yes, 150 clones per family. So we work right now in total with 16,065 clones. And we are right now selecting one. Some of these clones didn't tuberize in San Ramon because of the heat. So that is select. Okay. I don't know. And right now we are in a phase of, we're in the middle of the campaign. We are going to harvest in June and perform some evaluations of phenotypic evaluations, as I already told you. And
the most important of this part is that in all the process, also we are using the barcodes, and also we are extract the information of the seed families to the HideUp, because HideUp is connected to the pedigree book. And also we create the list, material list directly with HideUp, because it's impossible for us to manage the pedigree of the 16,000 genotype without to use the HideUp. And it led us to follow the identification of each clone for all the life of all the cycle, this recurrent cycle of selection in a breeding program. So the idea is like Chiara showed you is in the presentation that here we expected to, I don't know, you can show that slide. So this, we expected to we use the marker assisted selection in San Ramon for PBY, and also the idea is to select only the resistant materials in the next when the result to this first evaluation under field condition. The idea is to reduce in the second clonal generation that 15,000 clones. We the expectation is to reduce probably to the half of these clones. That like I hope we have going to the next generation only for the 7,000 clones. So the idea is to use to work together with marker assisted selection, use all these all technological tools in order to make a decision in real time and spend less time and support the accelerated breeding program in the case of the potato. So I hope you're to be clear in this part, and the idea is to show you how all these tools support our real life for a breeder, because it's not easy to put together all this. Without this tool, we can have a decision fast and select our new materials. So if you have any question, we are available to try to respond.
Yeah, okay, thank you so much for the wonderful presentation demo and also the nice summary. So now the floor is open for everyone if you have questions.
Hello?
Hello?
Yes, Kofi Bimpong here in Africa.
Hello.
Good afternoon, Kofi. Yeah.
Yes.
nice to meet you.
Yes. Actually, mine is just a clarification or omission. In the first presenter, after the crosses, he just said that the seeds are, after they count the seeds and then they store it. I was wondering, do you do QC for the F1 validation, or in YAM, in SIP, you don't do those things? I hope my question is clear.
What happened?
Hello?
Okay, can you repeat, please, because I'm more...
Okay, my question is, the first presenter just showed how crosses are done, how the seeds are counted, and how they are stored. I was thinking that we know, example in rice, it's not absolute. There's some little pollination within. I don't know in your crop. So in view of that, after we do our crosses, there is a need for us to do quality control, the F1 validation. I was thinking, do you do similar thing to make sure that the crosses are actually through cross before you store them?
Y así hacen análisis a las cosas antes de guardarlas.
Pero es que nosotros la variabilidad de los papeles.
No, él está hablando en caso de arroz.
I don't know.
Okay, so in potato, when we perform the cross, we select the pollen previously and we choose the female, and at the end we have a bulk of all the seeds within this cross. So we combine the seeds because are from the same female and male. In potato crop, there is like a variability in the F1, I think, that it's different from rice.
Yes.
So that's why we don't.
That was my comment, but thank you for the clarification.
Okay.
Okay.
Hi, this is Umesh from CIMIT. I got a question for you. Can you hear me?
Yeah, go ahead, Umesh.
The computer, that's the device computer, I'm interested to know how that is synchronized with your system. So you need a Wi-Fi network, or how is the different, do different people have different computers? How did that get into the database?
Okay. Right now, the device runs offline, so all the data is stored in the device. So that's why the breeder introduces a list of the users that are going to be used, that will use that device for that specific template. After all the technicians or the users allowed finish their part of the work, the report is generated. The report is generated per template. As I told you, right now the application works offline. No connection or no internet connection is needed right now.
Only the Pocket PC with the printer label is connected by Bluetooth, but they didn't require the internet in the moment to work in the greenhouse.
It's difficult in the field.
So, are there chances of losing data if this device just got dropped or damaged or something like that?
Okay. Well, the applications runs or creates backups of the database each day. So the only way to lose all the data is that the complete device is broken. But if the application cracks or there is backups of the database that are made frequently.
So once the device is connected to the system, then the database will be updated. So you have a database, phenotypic database, where all information will go, right?
Yes, exactly. Once the device is connected to a PC, we take the results and it is uploaded to the database.
Yeah, the problem is we can't have real-time update of the data.
Okay. Well, while the data is in the device, not yet. It must be uploaded by a person.
Mm-hmm. Okay.
Yes, because we need to review the template in order to clean the information, because the idea is to update in the database to the effective process, and also in order to follow to create after this the SIP number of each families, right? With the raw data also we can store it in the database, but the most important for us is we got the clean data in order to update in the next platform.
Okay, thank you.
You're welcome.
Any other questions, comments? Okay, so really appreciate, so Jazmin, you showed the crosses, crossing block and the devices, and also the inventory system, and the C, the pedigree management system from Roy. And at the end, it's great. Chiara, you showed high depth for data analysis platform. I think overall it's very impressive. I'm wondering from your own team, what do you see as the strength and the weakness of this relatively integrated breeding management systems, if any? And also, what's your vision and what's your wishes for, like, say, more adoption, or continue improvement?
Yes, also the
Las debilidades
Y las
las
fortalezas.
fortalezas del equipo, entendí yo.
¿Y cuál es
Y
la
el
misión
producto y la
futura?
visión.
Misión futura.
so also now start we need to also the adoption, because the idea is to the next step is we need to spread these tools for the example we need to install in Africa for potato breeders in Africa, in Asia, and also China, because the platform is done, but the adoption is I understand we need to more training our breeders in the regions, and other also we are trying to the sweet potato breeders try to adopt the system right now, because I know they have several problems nowadays in order to have this information in the database. But we are working together now with the sweet potato breeders in order to help and try to use this system. The next step for us is fix a little detail probably, but for the potato breeder is done, right? Because it's exactly that we request for the programs 5 years ago. Only I think the dissemination of these systems is the next step we need to do.
All right, that's excellent. You have some teams you are working with for supporting this training or deployment or dissemination? Or within your team only?
No, so only us, only the real team with the breeders are working the spread these tools. And also, but we are shared the source code. I want to show you something last slide probably. I don't know where is this slide. Okay, this is the idea. The CPROS in general, the source code was shared with the ITA and also to SIA the last years. And the idea is if they want, they can adapt it their crops. So we are discussion with Peter Colau and also with Trasha and with Dr. Hernan Ceballos and Augusto Becerra in case of SIAT. And last year we shared the source code for free. And we are trying today, we share all the acknowledgement in order if they want to adapt it in their crops, because they tell us that they have problem in their breeding program for yam and also for cassava, because they don't have a control or don't have this kind of system in his crossing blocks. No, they don't have all this system. And also we know that this system save several hours of the workman, because with the system permit to us to perform the work in less time, and also to be more effectively and avoid the mistakes in the information of the crossing management.
All right, thank you, Elisa. Hopefully, we will share all the presentation slides if you send to me in PDF format, and then also I recorded this, and then people in the GOBii emailing list will receive and they will contact you. And it's wonderful sharing, and I think it's very nice too. And looking forward to hear you get more feedback under the EIB file space. And we appreciate the EIB file work group 1. Kate introduced us the opportunity for your group to show this more in depth to the GOBii and EIB community. All right, with that, thank you for all to join and for the wonderful presentation. Thank you, the presenters again.
You are welcome, and thank you for hearing us. And of course, I am sharing with you the presentation in PDF format. And
Thank you very much again for your support.
Yeah. Okay, bye now.
Bye-bye.
Bye.